Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 48 of Physics 5054. We were discussing the temperature scales, and today we will go one step further in this regard, and let us understand the liquid in glass thermometers. Those thermometers which contain liquids inside a glass are called liquid in glass thermometer. Very commonly, we can use two types of liquid in glass thermometer. Number first is called laboratory thermometers, and the second one is called clinical thermometers. There is a difference. The construction and the working principles of both are about the same, not exactly, but about the same. But in case of laboratory thermometer, we are using these types of thermometers in laboratory. That is a bit longer one than the clinical thermometer. Both are portable. We can carry it very easily from one place to another place, even in the pocket, especially that clinical thermometer. So let us discuss the clinical and laboratory thermometer. But before that, ladies and gentlemen, whenever we are talking about these liquid in glass thermometer, we are considering three aspects. The first one is responsiveness. What is responsiveness? How quickly a thermometer is recording the temperature changes. How much quickly it is responding. On one side, there is a change in the temperature. On the other side, they are giving us the value. So we are saying the response of this thermometer is very quick. So in liquid in glass thermometers, we are checking one aspect, that is the first one, and that is the responsiveness. I wrote a technical definition of this. This measure how quickly a thermometer can register changes in temperature. So if a thermometer is responsive, then we are putting that in this category. Similarly, the second type of aspect we are seeing, that is the sensitivity. We are using this word very commonly in our daily life, but here we are going to learn the technical meaning of this. This measures the amount of change in thermometric property. For example, one thermometric property which we discussed in earlier lecture is the length of mercury column. They are very sensitive to the change in temperature. Just like we are seeing that this person is very sensitive, they are minding very small things. So similarly, if a small change is there, this type of thermometer is uh, measure that amount per unit change in the temperature. So sensitivity is the second category which we are seeing in these types of thermometers. The third one is the range. Range can also play a very vital role inside these liquid in glass thermometer. Range, the minimum and maximum uh, amount of temperature which these thermometers can record is called the range. All these properties, along with many other properties, we will discuss inside when we are specially discussing these types of thermometer. Ladies and gentlemen, laboratory thermometer, along with the main design feature, along with the purpose of those design features, are the working principles. This design feature is made because it will do these things. That is a very simple phenomena we will use inside this uh, discussion. Okay, first of all, let us see that what is the design of laboratory. There is a bulb. This area is called a bulb, which is a very thin glass. Why thin glass? We will discuss that here. But this is a thin glass, and inside the bulb there is mercury. We are commonly using mercury as a liquid in glass. Alcohol can also be used, but most laboratory and clinical thermometers are using what they are using these mercury. Now there is a glass stem, and that is mostly used for magnification purpose because this is very thin bore capillary tube. If we want to see it as a larger as a magnifying glass, then this glass is used for that particular purpose. So what is the range of this? The range is from minus 10 degrees Celsius to 110 degrees Celsius. This is the range of temperatures which mostly we are needing in the science laboratories, especially in physics and chemistry as well as in biology. So not less than minus 10 in the laboratory and not greater than 110 degrees Celsius is needed. So that is why this type of thermometers are specially designed for this purpose, to record the temperature in this range. Ladies and gentlemen, it is starting from minus 10 and it is going to 110 positive. Graduation is there, and this one small line is called 1 degree. So, this is the construction, this is the capillary tube, that is uniform one. Why we are using it as a uniform one, we will learn it in a moment. Okay, let us discuss the main design features of this thermometer keeping this construction. The first one is the mercury is contained in a thin wall glass bulb. In a thin wall glass, in a thin wall glass bulb. Why? This portion is thin because conduction should be there when you are recording the outside temperature in a laboratory, room temperature or a special ice or steam point. So if it is made very thick glass, so that then it would not allow the conduction of heat very quickly. So because we need quick conduction of heat, so it is made a thin wall glass bulb. And I wrote it here, allows conduction quickly to the liquid through glass. What is the liquid in this case? It is mercury. So the heat conduction is quick to the mercury. That is why we are using a thin wall glass bulb. That was the one. Continuing in this column, we are coming to the second main design feature. The bulb is made small to contain small amount of liquid. Now if you compare this stem with the bulb is comparatively very small. This bulb contains the amount of mercury. And why this feature is introduced? Because small amount of liquid respond more quickly to the change in temperature. This is a small amount of mercury. It means quick response. The response will be very much quick. If this is made like this, big one, and there is a mercury inside this, so when we are recording the temperature, this large bulb will respond very slowly, because first it will absorb the heat, and then raising the temperature will take time, which is not a good quality of the uh, thermometer. So the bulb is made small. There will be a small mercury, and when there is a small mercury, it will quickly respond to the change in the column of the mercury. So that is why a small amount of liquid responds more quickly to change in temperature. That was the second feature, design feature, and the purpose. The third one is the bore of capillary tube is fine and uniform. Now you can see there is a very fine capillary tube inside it that is made for a purpose. And you can see that this is uniform. Uniform means that everywhere that is the same. If it was not uniform, then you would not be able to get the correct temperature of the body. So this feature is introduced for this purpose. Fine tube allow a noticeable movement of the liquid column. For a small change in temperature, you can notice the movement that temperature is changing. If the whole of the glass stem was used to see the change, that would be difficult, that whether it is changing or not. But if it is a fine capillary tube, so it means that it is showing the movement. If we see, yes, the mercury level is increasing or decreasing. In case of big capillary tube, that won't be possible. Okay, the fine tube allows noticeable movement of the liquid column for a small change. And the second one, uniform, what does it mean? The uniform tube ensures even expansion of the liquid, that is evenly expanded. Now let me give you a display. If it is this much apart here and then this much apart here, so that won't be uniform, because filling this is requiring one amount of liquid and filling this area will require another amount of liquid. First it will fill this area and then it will increase. So non-uniformity is not the good design feature. So that is why it is kept uniform. So uniformly the mercury level will increase. Okay, ladies and gentlemen, the next one, the fourth one, is the wall of the long tube above the bulb are made thick. We are talking about this area above the bulb that is thick. Why? I told you earlier that it is playing the role of magnifying glass. This acts as a magnifying glass. For what purpose? For easy reading of mercury column. We can see easily if it is very, capillary tube is very thin. So if there is no magnifying glass, we won't be able to see the mercury level, and as a result we would not be able to record the temperature. So that is why thick glass is used above the bulb and thin glass is used below the bulb. Now, ladies and gentlemen, the fifth design feature is the size of thermometer is relatively small. Not that much small as compared to the clinical thermometer, but this is also small. You can put it in the pocket to carry it from one place to another place. So that is why the size of thermometer is relatively small. Why? This cheap, because if it is small, so it will be cheaper. If it was large, more design features were needed, so it could be costly. It is cheap, one, that is why it is small, and portable. The main purpose is portable. Portable means that you can carry it without any hindrance from one place to another place. That was the whole story about the laboratory thermometer. Now let us turn our focus to the second one, and that is the clinical thermometer. So I am writing this is clinical thermometer. Now, clinical thermometers are used by the doctors and nurses, many other people at homes. They are measuring the temperature of human bodies. So, keeping in mind those human bodies aspect, the design features are introduced inside it. Now, the construction and design is 98% is the same, with the only exception that there is a construction. Construction is like this. So, there is a hump above the bulb. Why? We will discuss that what is the need of that hump in the clinical thermometers. But before that, let us discuss different part. This is mercury, which is denoted in this case by red. It is a silvery shining material, but here to differentiate it from the other, I made it is red because I have the red marker with me. So you consider it as mercury. Okay. The second part is there is a hump, if you can see, and that is called contraction. Constriction. This is not contraction. This is constriction. 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 Again, in this case, there is a bulb with thin walled glass, and there is extra fine bore. This capillary is more thinner than this capillary tube in the laboratory thermometer. So here, ladies and gentlemen, the range is different from this. Here the range is from 34 degrees Celsius to 43 degrees Celsius. Why? Because the human temperature is 36.9, so it should be in the range of that. We will never observe minus 10 degrees Celsius of the internal body temperature. So keeping in mind the human conditions, they design this one. There are many design features. The first main design feature is the glass of the bulb is thin. Here we also said that the glass is thin, and it means that it is rapid conduction of heat, means it is sensitive. Rapid conduction of, if it was a thin wall, then conduction won't happen to the thermometer. So this is one design feature. The bore of capillary tube is very fine. Why? Large change in length for a small change in temperature. So we bore is very fine, means that it can record large changes in length for a small change in temperature, because we are having from 34 degree to 42 degrees Celsius. So there is a very narrow range of temperature this thermometer can record. So the capillary is very fine, so you can clearly see that the temperature changes is occurring. If the capillary was big, so you won't be able then to see these changes. For that particular purpose, the bore of capillary tube is very fine. Now the next part is the range, and I told you range is limited to 34 degrees Celsius to 42 degrees Celsius. From 34 degrees Celsius to 43 degrees. Why it is like this? Why not minus 10 in this case? Because normal body temperature is 36.9, so it is coming in between these two minimum and maximum values. And the main purpose of this clinical laboratory, this clinical thermometer, is to test the temperature of human beings. So The normal temperature is 36.9. So it might be smaller than that or a bit larger than that. So that is why the range is kept in 34 degree to 42. I told you that range is also an important aspect of these thermometers. Now, the next one is narrow construction above the bulb, and I was talking about this hump. Ladies and gentlemen, let me tell you that this construction is introduced because if we are recording the temperature of human body in a very cold place, when we are putting this thermometer in the mouth or in the armpit, so it is recording and the movement of that mercury can be observed very easily. But when we are getting it out of the mouth of the patient, so because the environment is very cold outside, so that mercury level can come down very quickly to the bulb again, and when we are seeing it we won't be able to record the correct temperature. So that is why a construction is made there. So when you get it out from the mouth of patient, this thermometer, so it will not fall down very quickly to the bulb, and that is the main purpose of this construction. uh, in a cold environment, the narrow construction above the bulb ensures that the maximum temperature of the body is recorded and correctly recorded. Because if there is a cold environment and it is sensitive to the environment change, it will come down very quickly to the bulb. The next is the cross section of the stem of the thermometer is pear shape. You can see that it is a pear shape. Again, this is because you can see that a pear shape is like this. This is a pear. So when you are seeing a pair, one is thin and the other is larger. So this is a bigger one, this is a bigger one, and this is a smaller one. Why this pear shape it is made? It is made as a magnifying glass. Here we also discussed that it is playing the role of magnifying glass. Here I am saying the cross section of the stem. The stem is just like what it is in the form of pear shape. So acts as a magnifying glass for recording of mercury thread. So when you want to see it very clearly, so it should not be uniform with that bulb. So then recording and seeing the temperature by the observer will be very difficult. So these are the different types of thermometers which we discussed. Ladies and gentlemen, one more thermometer is remaining, and that is called thermocouple thermometer. One is called liquid in glass thermometer, and there is another type of uh, thermometer which is called thermocouple. Tomorrow, inshallah, we will conclude this theoretical portion with the topic of thermocouple. Don't miss, that is very important, the use of that, and then we will start also the uh, exercise as well. So be in contact. Take care. Allah Hafiz.